If it seemed like the first two organs were pretty quick, that's because you were right. Most of the digestion that occurs in our body doesn't really occur in the mouth and the stomach. I mean, the mouth has salivary amylase, and it'll break down carbohydrates, and the stomach has pepsin, which will break down proteins into smaller polypeptides or peptides. But everything else, breaking down the polymer into the monomer, happens in the small intestine. When food goes from the stomach and it becomes acidified with the HCl, it will eventually move, and this part of the stomach, it has another sphincter. It's called the pyloric sphincter, and food will move through the stomach and it will enter the small intestine. Now, what's interesting is that at this point, pretty much our physical digestion is mostly finished. Like the teeth did the mastication, and that helped to increase surface area of food. And the stomach will churn and will break down food even more, and the acid and the enzymes will help break it down even more. There isn't a ton of physical digestion that occurs from now on. It's mostly chemical. So as food is coming past the stomach, it's going past the pyloric sphincter, it's going to make its way into the small intestine. But the small intestine, it's broken down into three components. Right here is the duodenum. The duodenum follows immediately after the stomach. And it's here in the duodenum that digestion first occurs. There are two accessory organs. One is called the gallbladder, and it's over here. Gallbladder in green, and the pancreas in yellow. And notice the gallbladder is also somewhat attached to the liver. These accessory glands, food doesn't actually travel through these glands. These glands squirt digestive chemical enzymes onto the food to help break it down even more. So, food leaving the stomach is referred to as chyme. So I'll just put it right here. Chyme. It's often called acidic chyme. Now, the big problem is that the chyme has a pH of around 2. And that is, sulfuric acid can have a pH of around 2. That's a pretty strong acid. And so, unlike the stomach, which has a continual layer of mucus being replenished, the duodenum does not. And so, one of the purposes of the pancreas in yellow, I'll just write that here, the pancreas, one of its main jobs is to secrete a chemical called bicarbonate. So secretion of bicarbonate ions. And the purpose of that is to neutralize acidic chyme. The pancreas is also responsible for secreting a bunch of other enzymes. The biggest one that you have to know is an enzyme called lipase. And if that sounds like you know what its substrate is, you're right. Lipase is an enzyme that breaks down fats and converts it into its subunits, glycerol and fatty acids. Which is great. Glycerol and fatty acids are actually small enough that they can be absorbed into the body. So this is like a one step. Now, unfortunately, fat tends to glob itself up. And by that I mean, if you were to have a fat globule in the body and you had an enzyme and the enzyme tried to act on it, there's not a ton of surface for it to get to. And fat tends to glob together even despite breaking it down with acid and teeth. And so if we had some way to increase the surface area, and so by that I mean if we had some way to take the same volume but just break it apart. I mean, the volume of this was 4 squares, and this is 1, 2, 3, 4 squares, but look how I've increased the area. I mean, this would have 1, 2, 3, 4, 5, 6, 7, 8 centimeters of surface, but this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This one has a drastically increased surface area. How does the body take a large fat globule and separate it so that an enzyme like lipase can get in there and do its job? And that is where the gallbladder comes in. The gallbladder and the pancreas actually share, I'll show it here, they actually share a duct, and a duct is just where they secrete their digestive juices. So the pancreas, like I said, it's going to secrete lipase, and the gallbladder is going to secrete a substance called bile. And bile, or sometimes called bile salts, they act as an emulsifier. An emulsifier simply means emulsifies fats. It simply means to physically separate them. Fats to increase surface area. That's the purpose. And that's why they share a duct. I mean, the gallbladder stores bile, and it'll shoot it into the duodenum. And the pancreas will secrete lipase. And so it's like the yin and the yang. They work together. And once the fats have been emulsified, then lipase can come in there and do its job. Fun fact about the gallbladder, it just stores bile. It doesn't make it. That's the liver's job. The pancreas isn't done, though. The pancreas can secrete a lot more enzymes in addition to the bicarbonate ions I just mentioned that help to neutralize the acidic chyme. In fact, after bicarbonate ions are excreted through the common bile duct, it brings the pH of the brings the pH of the food in the duodenum up to about 7 to 8. So kind of basic. There's a ton of other things, and I had to pull up a big list because the pancreas, not only does it release lipase and bicarbonate, it also releases a bunch of other enzymes like carbohydrases, like nucleases, like trypsinogen, and another one, enterokinases. Whew, the pancreas does a lot, and I'll just go through it one by one. The most important things: bicarbonate, lipase, and I already talked about that. Carbohydrases are just a class of enzymes, you guessed it, that break down carbohydrates. So you'll recall from the mouth that salivary amylase will break down carbohydrates. There's a type of pancreatic amylase. So pancreatic amylase, that's a weird S. Pancreatic amylase breaks down starches even farther, so that they basically turn into glucose monomers. Nucleases, you guessed it, they break down nucleic acids into basic nucleotide sequences. Trypsinogen, it's not really clear from its name what trypsinogen does, but trypsinogen helps to break down proteins. So it will take those peptides. You'll recall from the stomach that pepsin takes protein, breaks it down to polypeptides, or polypeptides down to peptides, and trypsinogen will take peptides and turn it back into amino, or break it down farther into amino acids. And it's these amino acids that are small enough to be absorbed into our bloodstream. This class, the enterokinases, they are simply an activating enzyme. And you could think of them as a cofactor. Think back to the enzyme lecture, a cofactor to trypsinogen. It turns trypsinogen into its active form, which is called trypsin. So activating trypsinogen into trypsin. Trypsin, you could think of trypsin as the active form of the enzyme that breaks down amino acids, breaks down proteins. What I've underlined, I'm not going to lie to you, enterokinases never comes up on a test, not even in non-COVID times. The things that you have to remember is you have to remember lipase, bicarbonates, pancreatic amylase, and trypsinogen. So when people have pancreatic cancer, it makes it really difficult for them to digest foods, specifically fats, because there is no other organ that secretes lipase. So somebody's diet is going to have to be modified. You don't want too much fat building up in your duodenum, because once your body detects a ton of fat globules, then your body releases a lot of bile. And a lot of bile means, the volume and frequency of your stool is going to dramatically increase. In fact, there was a competitive inhibitor for lipase invented. It was revolutionary. They're like, oh man, if we just shut down lipase, then we can't break down fats into fatty acids and glycerol, and then the body will never absorb them. You can eat all the fat you want, and you'll never enter your body. And that was true. It's just that bile starts to get produced to try and emulsify all the fat. And because it's not being broken down, the body releases way more bile than it should. And the side effects are things like explosive diarrhea and things like that. So the drug had a lot of side effects, to say the least. Back to the liver for a second. Hi, liver. While we're here, it is considered an accessory organ, and yes, it does manufacture bile. It also does a couple of things. The liver helps to break down fats that enter into our lymph system, and they also actually break down hemoglobin and red blood cells. So when red blood cells are kind of getting too long in the tooth, it'll destroy them and kind of recycle them and reabsorb the nutrients to the body. The liver also stores glycogen, and that was mentioned last week. Glycogen, of course, is basically a polymer of glucose, and when too much glucose is in our bloodstream, then the liver will convert it into glycogen. And if we still don't burn the energy, maybe we've been inactive, then the glycogen will turn into fat. The liver, because the liver actually produces the bile salts, that's actually what gives our feces the color that it does, that dark kind of green color. And the liver also metabolizes vitamins A, B12, and D. Fun fact, don't eat a polar bear's liver. It has a bunch of vitamin A. Vitamin A is fat soluble. It tends to be absorbed very, very quickly, and we can't really stop or halt the amount. Like some other vitamins, like vitamin C, you read the nutrient labels. Oh, this has 200% of your daily intake of vitamin C. It's really hard to overdose on that. It's really easy to overdose on vitamin A. Too much vitamin A can actually lead your liver to shut down. And you need your liver because it removes many toxins and harmful substances from your body, like alcohol. The enzyme alcohol dehydrogenase is found in your liver, and that's the thing that breaks down alcohol into harmless sugars. There are some digestive problems with the gallbladder. Things like sometimes the salts tend to crystallize and they can get stuck in the gallbladder, and that leads to gallstones. There's also two disorders, one called jaundice and the other called cirrhosis. Jaundice is a yellowing of the skin and tissues. That's when you have an accelerated destruction of red blood cells in your liver. And so your bile pigments are not excreted and they start to accumulate in the body. So your blood and your eyes start to appear really yellow. That's what they say when you appear jaundiced. And being jaundiced is kind of people that have liver failure, the whites of their eyes turn yellow. Cirrhosis, I should be writing these down. So jaundice, that was the first one. Jaundice. Cirrhosis is chronic inflammation of the liver, and it's usually caused by nutritional deprivation or infection. Cirrhosis, the liver looks like it's shriveling up and it changes color. Sometimes cirrhosis is caused by massive alcohol or lifelong alcohol abuse, but failure of the liver is going to result in the two of those, jaundice and cirrhosis, and you really need your liver. Yeah. So that's pretty much it. To sum up, most of the chemical breakdown of food in your body happens in the duodenum of the small intestine. So really early on. Your two accessory glands, your pancreas and your gallbladder, are intricately evolved. The pancreas will secrete bicarbonate to help neutralize the acidic chyme coming from the stomach, and it'll also secrete the enzyme lipase, which breaks down fat. And the gallbladder, to help emulsify fats and physically separate them, will release bile salts. The bile salts are originally manufactured in the liver. Please pay particular note to the enzymes additionally secreted by the pancreas, so carbohydrates like pancreatic amylase, nucleases, and trypsin, as those are the big chemical digestive enzymes that break down our macronutrients into our monomers. Cheers.